Good morning, children. In today's class, we are going to learn about measures of dispersion. Have you heard this word disperse? Yes. During assembly in schools, we say school disperse. That tells us spread out and back to your class. So dispersion decides about the nature of spreadness of data. Look at these two examples. We have two types of data given here. 10, 20, 50, 80, 90. If I add it all, it is 250 and the average is 50. Look at this 5 data. Again, when I add it all and I divide by 5, again the average is the same. For both the problems, the average is same. But are the data one and the same? No. Here, the minimum value 10, whereas the maximum value 90. Here, the minimum value 48 and the maximum value is 52. The range is less. So, average alone does not give a clear-cut idea about the data. Definitely, we need to supplement with some other measures, and dispersion is one such measure. Remember, when you say your mark at home, parents are much interested in knowing who got first mark, how many of them failed in the class. So that will give you an exact performance of their own child. So dispersion deals about the nature of spreadness of data. The spread is calculated in terms of distance, in terms of average. Distance, when I say, it is done using range, quartile, deviation. Range, we have studied in lower class the difference between the highest and the lowest. This year, we are going to concentrate on quartile deviation. The other name is interquartile range. We know lower quartile is termed as Q1, upper quartile is Q3. Find the difference, divide by 2, which gives us quartile deviation. Now we need to know what is coefficient of quartile deviation. Q3 minus Q1 divided by Q3 plus Q1. Now, back to the spread in terms of average. When I mean average, I have mean deviation and standard deviation. We have already learned about standard deviation in standard 10. So this year, we are going to concentrate on mean deviation, abbreviated as MD. This mean deviation, I can calculate using mean or median. Mean, when I say, deviation tells me the difference. Your mark minus class average. So like every child's mark minus the class average, find the modulus of it. Because if I don't take modulus, this will lead to 0. So naturally, some are above the average and some are below the average. Summation will give me 0 if I don't take modulus. So, we take modulus of x minus x bar, sum it all, divide by n. If I include f for discrete data, I just change x as the middle of the class interval if it is continuous data, as we had discussed all this when calculating quartiles. Instead of x bar, which is called mean, if I replace median, I call it mean deviation about median. So mean deviation, you can calculate about mean or about median. Wherever x bar comes, just put median value to get mean deviation about median. Now again I need what is coefficient of mean deviation. If it is calculated about mean, divide by mean. If it is calculated about median, divide by median, and this is the formula list for today's problems. Exercise 8.1, question number 11, calculate quartile deviation and its coefficient. Given age in years and number of members. Let us call age as X and number of members as F, the frequency. Calculate something called cumulative frequency. Keep adding the very first value 13. 13 plus 61, 74. 74 plus 47, 121. 121 plus 15, 136. 136 plus 10, 146. 146 plus 18, 164. 164 plus 36 tells us 200. Remember, we will call the total frequency as N. To calculate quartile deviation, we need to know what is Q1, Q3, and then only we can substitute. What is Q1? The formula N plus 1 by 4th value. What is N here? 200 plus 1 by 4. What is the X value corresponding to this? So I get the value as 200 plus 1, 201 divided by 4 is 50.25. So we must check where 50.25 is crossing. So 50.25 is crossing here. So what is this class? This I call Q1. So the value of quartile 1 is 13. Now to find out Q3, remember the formula 3 by 4 of N plus 1th value. I calculate 3 by 4 of 200 plus 1th value. As we check, it is 150.75. You must check where this 150.75 is crossing. Here. So 150.75 is crossed here. The corresponding X value we call Q3. So Q3 equals 70. Now we need to find out what is quartile deviation. The formula half of Q3 minus Q1. That is half of 70 minus 30. It is 40 by 2. So I get 20. Now we need to calculate coefficient of quartile deviation. The formula Q3 minus Q1 by Q3 plus Q1. It is 70 minus 30 by 70 plus 30. Or I can say 40 by 100. Or the value is 0.4 and hence the problem is done. Question number 12. Calculate quartile deviation and its relative measure. Relative measure again stands for coefficient of quartile deviation. As we recall the two formula, we need to know what is Q1 and Q3. Q1. We recall the formula from the previous classes. It is lower limit plus N by 4 minus previous cumulative frequency by frequency of the quartile class into class interval's length. Same thing we adopt for Q3. 3n by 4 is the only change. To do it, let us find out the cumulative frequency. Keep on adding frequency. 5. 5 plus 10, 15. 15 plus 13, 28. 28 plus 18, 46. 46 plus 14, 60. 60 plus 8 is 68. As we calculate we must know the total frequency is given by this last number that we term as n. N equal to 68. So n by 4 is 68 by 4, that is 17. Check where 17 is crossed in the cumulative frequency here. So 17 falls here. So this I will call quartile 1 class, and the lower limit of this I call L, and this I call frequency. The previous I call PCF. As I know it all, let me write down. L equals 20. PCF, previous cumulative frequency, that is 15. F, frequency of the quartile class, that is 13. And C, the length of class interval 0 to 10, 10 to 20. How do they increase? They increase 10, 10. So length of class interval is 10. As I substitute, Q1 is 20 plus 17 minus 15 divided by 13 into 10. Let us simplify. 20 plus 1.53. So Q1 is 21.53. The same way we will go for Q3. Find out 3n by 4. 3 by 4 of 68. It is 51. Check where 51 is crossed in cumulative frequency. 51 falls here. So this class I will call quartile 3 class, and this number I call lower limit for Q3. This value corresponding to frequency of the quartile class call F. The previous cumulative frequency we call PCF. Let us tabulate the values. L is 40, PCF is 46, F is 14. Substituting, we get Q3 equals 40 plus 51 minus 46 by 14. The whole thing multiplied by 10. It is 40 plus 3.5714. It is 43.5714. As I know Q1 and Q3, let me substitute in quartile deviation. QD equals 43.5714 minus 21.53 divided by 2. As we simplify using calculator, we get 11.02. Now we need to find the relative measure of quartile deviation called as coefficient of QD. The formula Q3 minus Q1 by Q3 plus Q1. 43.5714 minus 21.53 by 43.5714 plus 21.53. As we simplify, we get 0.3384. So coefficient of quartile deviation is 0.3384, and hence the problem is done. Question number 13. Compute mean deviation about median. Let us remember, median is the middle value. How to calculate? N plus 1 by 2th value. What is this N? Total frequency. To calculate this value, let us first find out cumulative frequency. Very first value 15. We call this as F and this as X. 15 plus 20, 35 plus 32, 67 plus 35, 102 plus 35, 137 plus 22, 159 plus 20, 179 plus 10, 189 plus 8. So the total frequency, we get 197. Now median is 197 plus 1 by 2th value. As I simplify, I get 198 by 2, that is 99th value. Check in cumulative frequency where 99 is crossed. 99 is crossed here. So this corresponding X we will call median. So median value is 61. Now to find out mean deviation, let us calculate X minus median modulus of it. Modulus of what is the first value? 58 minus middle value, that is median, 61. I get minus 3. Modulus tells me 3. 59 minus 61. I get minus 2. Modulus is 2. 60 minus 61. I get minus 1. Modulus is 1. Proceed in the same way. As we complete this deviation, we call it as modulus of D. Now, to substitute in the formula, I need sigma f into modulus of D. So, modulus of D multiply with f. F into modulus of D. 15 into 3, 45. 20 into 2, 32 into 1, 35 into 0, 35 into 1, 22 into 2, 20 into 3, 10 into 4, 8 into 5. Let us total it all. Call it as sigma f into mod D. It is 336. As I substitute, it is 336 divided by n is 197. As we divide, we get 1.7055, approximating which I get 1.71 as the mean deviation about median. Question number 15, the same pattern, we are going to find mean deviation about median. Here, coefficient is asked. Let us proceed in the same pattern. Given class intervals and frequency. To get median, we have the formula L plus n by 2 minus PCF by F into C. Let us calculate what is n by 2. To get n, calculate the cumulative frequency. 8. 8 plus 12. 20 plus 16. 36 plus 20. 56 plus 37. 93 plus 25. 118 plus 19. 137 plus 13, that is 150. We call the total frequency as n. As I know n, let me divide 150 divided by 2, that is 75. Check where 75 is crossed in cumulative frequency. Here. So 75 is crossed here. So this class we call as the median class. And this number I term L. And this frequency we call F. The previous cumulative frequency let us call PCF. As I know all the values, let me substitute. Here the length of class interval 0 to 10. It is 10. L is 40. PCF we get 56. F we get 37. As I substitute, median equals 40 plus 75 n by 2 value minus 56 divided by F into 10. Simplify. Using calculator, we get 40 plus 19 by 37 into 10. which is 5.1351. Adding together, median is 45.1351. To calculate mean deviation, what is the formula for mean deviation? It is sigma f into d divided by n. Here, deviation is modulus of m minus median. What is m actually? The middle value of the class interval. 0 to 10, middle value 5. 10 to 20, 15. 20 to 30, 25. Calculate in the same way, 35, 45, 55, 65 and 75. Deviation m minus median. M value minus median is 45.1351. As we subtract 5 minus 45.1351, it is 40.1351. Subtracting in the same way, 30.1351, 20.1351, 10.1351, 0.1351, 9.8649, 19.8649, 29.8649. We need to calculate f into deviation. F is the number of percent. So this column and this column we need to multiply. As we multiply and fill, the total of f into d, as we simplify, we get 2224.8636. Substituting in the formula n as 150, as we divide we get 14.8324. The question is to find the coefficient of mean deviation about median. The answer is MD by median. MD 14.8324 by median is 45.1351. As we simplify, the answer is 0.3286, or I can approximate it as 0.33. Here we can say 14.83 also. Question number 14. Compute mean deviation about mean. To calculate mean deviation about mean, first of all, we must find out what is mean, the data given as class interval and frequency. Very first step, calculate m, the middle value. 0 to 5, middle value 2.5. 5 to 10, 10 to 15, 15 to 20, 20 to 25. So very first step, we calculate m, the middle value of each interval. Now this and this I need to multiply f into m to get mean value. 3 into 2.5, 5 into 7.5, 12 into 12.5, 6 into 17.5, 4 into 22.5. As we add it all, I call it as sigma f into m. It is 390. Find out capital N, the total frequency. It is 30. As I know these two, what is mean? Let me remember the formula sigma fm divided by n. It is 390 divided by 30, that is 13. So I have achieved mean value which is 13. To get mean deviation, find out the deviation modulus, that is m minus mean value, or mean value I call x bar. So I can write it is m minus x bar. 2.5 minus 13. My answer is minus 10.5, but modulus tells me plus 10.5. 7.5 minus 13. I get minus 5.5, modulus is 5.5. 12.5 minus 13. Minus 0.5, modulus tells me 0.5. 17.5 minus 13. It is 4.5. 22.5 minus 13. It is 9.5. Calculate f into mod d. F value here we have in this column. This is modulus of d. 3 into 10.5. 5 into 5.5. Like this, let us multiply. We arrive at the total 130. Let us remember the formula mean deviation about mean. Sigma f into modulus of d divided by n, where d is m minus mean. As we simplify, 130 divided by 30, we get 4.33. In today's class, we have learnt about mean deviation using mean or median. Mean, the formula sigma fm by n, whereas median for ungrouped, discrete and continuous we learnt in the previous problems. Mean deviation, the same formula holds, but D stands for m minus mean if it is about mean, m minus median if it is about median. Let us be thorough with the formula to practice these problems easily. Thank you.